In this question, we're going to look at a double integral. Calculate the integral of x squared y plus 3y cubed over the rectangle R defined by x between 1 and 2 and y between 2 and 4. Now, if you actually look at the limits of this rectangle, these limits are constant. X is just between 1 and 2. Y is just between 2 and 4. The limits for x don't depend on y. The limits for y don't depend on x. So actually, this integral can be done in either order. We can write this either as the integral for x between 1 and 2 of x squared y plus 3y cubed dx. That's the inner integral, and then the outer integral is the integral between 2 and 4 of x squared y plus dy. So we can write it in that way, or we can write it the other way around. So now we'll do x squared y plus 3y cubed dy dx, and the inner integral is with y, so the inner integral is between 2 and 4, and the outer integral is dx is between 1 and 2. Okay, so we'll do both examples, and we should get to the same answer with both methods. The key is that when we're doing integration like this, we always do the inner integral first and the outer integral second, and when we're doing the inner integral, we treat the other variable as a constant. So on the left, this first example, on the left hand side, we're going to do the inner integral first. So we do the integral of x squared y plus 3y cubed dx. Well, this is an integral with respect to x, so we're just going to imagine that y is a constant. So the integral of x squared y dx, where y is a constant, is just x cubed y over 3. And plus 3y cubed, again we treat y as a constant, so this is just 3y cubed x. And this is between 1 and 2. And we still have the outer integral that we haven't done yet. So now the inner integral we're going to do just like any standard integral. We have to substitute in the limits, and now remember these are limits for x, so we get x cubed y over 3, that's 2 cubed y over 3, that's 8y over 3, plus 3y cubed times 2, so that's 6y cubed. And then we're going to take away the lower limit, so it's take away, if x is 1, we get x cubed is 1, we get y over 3, and we also have to take away the second term. If x is 1, we just get 3y cubed dy. And now we've sort of eliminated x from our integral, so we're down to now just a simple integral in y. We can simplify this a little bit because we have some like terms. 8y over 3 minus y over 3 is 7y over 3. 6y cubed minus 3y cubed is plus 3y cubed dy. And this is now just a normal integral with respect to y. 7y over 3 turns into 7y squared over 6. When we integrate, 3y cubed turns into 3y to the 4th over 4. And this is between 4 and 2. So then the upper limit is 7 times 4 squared. That's 7 times 16 over 6. Plus 3 times 4 to the 4 over 4, that's 3 times 256 over 4. And taking away the lower limit, that's 7 times 2 squared is 7 times 4 over 6. We take away the lower limit minus 3 times 2 to the 4 is 16, so 3 times 16 over 4. And this is just a big number that you can plug into your calculator. It simplifies down, but if you do all this calculation, I think you just get 194. So that's the sort of final answer to this integral. As I said, because it's a simple integral over a rectangle, we can do it the other way around. So let's have a look at the other way around, where we integrate with respect to y first. So that's the inner integral, and then with respect to x. So you see we have dy dx rather than dx dy. And similarly, the limits of the integration are swapped around. So let's try this. Same idea. We'll do the inner integral first. We're integrating with respect to y. Imagine that x is a constant. So we're going to treat x as a constant. The integral of x squared y dy with x a constant is just x squared y squared over 2. And the integral of 3y cubed with respect to y is 3y to the 4 over 4. And this is between 2 and 4. And we still haven't done the outer integral dx. Now let's substitute in the limits for this inner integral. Remember this inner integral with respect to y, so we're going to substitute in these values for y. So we get y squared, 4 squared is 16, x squared over 2, plus 3 times 4 to the power of 4, that's 4 to the power of 4 is 256, isn't it? So we get 3 times 256 over 4, and then we take away the lower limit, so it's y squared, 2 squared is 4, so it's minus 4x squared over 2, and minus 2 to the 4 is 16, 3 times 16 is 48 over 4 dx. Okay. Now this all simplifies down the inside, so 16x squared over 2 minus 4x squared over 2 is just 6x squared, and 3 times 256 over 4 minus 48 over 4 just gives us 180. Okay, so now we've completely eliminated y, and we can just do a normal integral with respect to x. 6x squared integrates to 6x cubed over 3, and 180 integrates to 180x. Limits are 1 and 2, so we're going to substitute in 6 times 2 cubed, that's 6 times 8 over 3, plus 180 times 2, 360, and we take away 6 times 1 cubed over 3, that's 6 over 3, and we're going to take away 180 times 1, so let's take away 180. This is fairly straightforward now. We just get 16 plus 360 minus 2 minus 180. That's 180 plus 16 minus 2 is 194, which is the same answer that we got before. So we're obviously pretty satisfied that we got the same answer both ways. We probably did it correctly. Obviously in an actual exam question you only have to do it one way. It's up to you which way around you prefer to do it.